So we are addressing the use of GDAL for the HDF and also NetCDF. So whatever you do GDAL info, you can get the structure. Here you have the typical projection information, and here you have pixel resolution and extent. Okay, so the part that you have to use it inside GDAL translate is all after the equal. You will have HDF4, and then you will have this long string that goes until to the end, and in this case is the NVDI. So if you take this string and you do GDAL translate in front, and then output, you will get that one as a file. Okay, and then it's the same for the VRT. Okay, so be careful because each one of these will be one band. Okay, so once again you have to do like this. Okay. So you will have, now I don't have the file, I don't know what it is, but this is the concept. So you will have GDAL translate with all the typical compression and so on, and then you do dot test dot diff. So this one is going to be only one band for this. Okay. The same is going to be for the VRT if you want to build a VRT. But be careful because this one means that the file is under the home. Okay, if it's in another directory over here, but this one will give you by the GDAL. If it's another directory, it's going to be under home / SE data, for example, blah blah. So over here you will have is a nested path. So it's quite tricky. Now let me run if I have this way you can also see, but I don't think I have find. So this is also good for finding name in all my directory. Any file that is HDF. I don't think I have it, no, neither NetCDF. We need to download it. Okay, but this is the concept. So this long string that once again you get it by the GDAL info. So GDAL info will give you immediately this, and for the NetCDF also. So maybe in meantime that we play a bit, you can do the GDAL info of your NetCDF, and you can see a very similar string. Of course, you will not have HDF4, but you will have NetC. Okay, and then with that one, you can create a TIFF. It's going to be the input for the TIFF for one leg. Okay.
So so if I have a lot of them, then I would do like essentially this line, but with like stars. I got all the NetCDFs and then loop through this list.
Not really. I think you need to extract all. So if you want to do a VRT, or let's do a VRT because so you have to do it the first string. Okay.
Have to do some string manipulation within the loop.
And like always, you will have a lot of these strange characters that it will give you a lot of headache. But this is the concept. So over here, you will do the GDAL big VRT. Okay, so this one is going to be your out.VRT. And these are going to be the first input and the second input. In this case, you will do the separate to have to have one band and second band. But again, here probably you will need, because you have the two quotation here that are always, so you will need once again to put some single quotation here, and yes, and in the end, so you need to play a bit with this one because it will give you a bit of problem, this kind of syntax. But this is the way how to export. So maybe you can prepare one line with your NetCDF, and we can show to the folks.
I think my NetCDF is a bit easier. Like it's stored as bands. Like I can access them with -b/1 or -b1.
Yes, that one also. And actually, in GDAL translate, there is also one option. I think they say somewhere sub data set or something like this. Or maybe it was in GR1 or one of the two. It's something new that they didn't test that is use it for enter inside to these next CDF and the HDF data format. Okay.
Yeah. But I guess my question was like, I do have to
here sub data set. Look.
Sub data set. So I do have to call every sub data set individually. I can't. There's no command that says converts all of these bands into one BRT. Okay.
No.
Okay. Well then,
I think also if you maybe if you are lucky, your next CDF has only band, has not sub band, and maybe you can pass the full net CDF.
No, you get a warning telling you it only uses the first one.
Perfect. So you have to give. You have to give. So probably you did something like this because it does not have sub data set and that one work. So you did band one.
Yeah.
Input NC output band one to TIFF, okay?
Yeah.
But then you have to get the second TIFF and so on. So probably with the build VRT, you will be able to start one shot. I mean, like this one is the build over here. Okay, and then this one will be multi-band and will be easy to convert. Okay. Okay, very good. Okay, then I think Olivia was ready to talk before.
Yeah, I did have a smaller question. So last time you talked about setting up variables to hold like the input and output directories, which makes sense since I've done that in other programming. But so I was trying to do that in Jupyter Notebook. And I think that so I would had like one code block that had like the input output as variables, and then I tried to call them in the next output in a different block, and that didn't work. So
yeah, you're right.
Is that just how Jupyter Notebook works?
Yeah, Jupyter Notebook doesn't. If you set up in one variable in one cell,
block,
that
cell,
is in the block or cell, it will not be transferred to the second one.
Okay.
Directly. You can try something that I didn't try so much. If you put, you have your var equal your $SC data, the typical. Okay, you can try with the word export, but
I have come across that.
Try.
Might not.
May not.
Okay.
It's really, I didn't Google it. It could be that it's possible to make them, because in this case they call a local variable a global variable. So this is a local variable, and as soon as I close this terminal, it's gone.
Yeah.
Okay, so it could be that there is a way to make this one available for other process, but I didn't investigate. So so once again, if you want to go really in the coding and live with Jupyter, feel free to use Emacs. Okay, so you have directly in the terminal here in your test.sh. Okay, and now that you are working Bash, the sh stays for Bash. So this one is going to be your script. Okay, this is for everybody, very useful. So for example, this is going to be your script that you do echo and you start it, okay? Okay, then there are some shortcuts that if not, you can start like this, file save, or you can see with Control C. If you do Control CS, you save it. And Control XF, you save it. Okay, and then you want to run it this one, you do Bash, okay, test sh, and then you print whatever it is, say the script to do it. Okay, so this is how the programmer works. We don't work with you.
Yeah, okay. I was wondering, someone last time brought up that they were working in that. I was like, oh, that would be nicer.
Yeah, it's over here, okay?
Yeah,
the advantage
with Emacs.
Yeah, perfect. So the advantage for someone that want to be a bit more advanced in this, you have Emacs also in the terminal. So what does mean? If you run Emacs over here with the test.sh with the same file, let's put in one, and we stay for no windows. What does mean that the terminal now is your scripting, and this is better when you're working remotely. When you log into a server where you have the Linux over there, this is the best way, even with my to my internet, mobile internet. Okay, because when you open, this is called X11 Windows. Everything that you open as a Windows is the X11. Okay, and the X11, of course, is more heavy if this file is not in your computer, but is in the computer over there. So if anyone has access to remote desktop with Linux in HPC, or the best way is to work in this way. So here you type your script, and then when you save it, and here you have to use shortcuts, Emacs shortcuts that usually I always use the saving, XS, and the closing, Control C. Okay, XC. Run the script, yes. Yes. Okay, so now I have these two files, test1 and test2. Okay. So now I can run one of the two, okay? We will do the same. Okay, sorry. Okay. So feel free, if you are working only with the with the virtual machine, feel free to use this one. Rather, if you start working in a remote desktop, use the Emacs ND, okay?
And then, so when you use Emacs and it's like a file that like doesn't exist already, it like creates it.
Bravo, yes.
And then
yeah,
if it exists already, does it just open it?
Yes, if
Okay.
it exists, already open. Perfect. In other words, I want to say now I close it, test1 sh, and now I do okay, let me open again. Okay, and once again, if you put the and over here, means that you send it to the background. So as you can see, I'm opening the same file than before. And now the terminal is still available for you. It's not holding to these Windows X11. And I'll give you the same example, but without. Okay, so if you don't put the and, you do like this, this one is still working, but this one doesn't work. Okay, you can't type here. Okay, there are some tricks for someone. You do Control Z, and then you stop it. You're going to give you the stop. So I'm going to stop this one, and then over here you do BG background. You send it to the background. Okay, so now look, it's giving to you perfect the same. Okay, so this is just to webs, but usually always start with the and. In this way, you have the terminal for you ready, and you can test it in the meantime. Because usually what I do, I test one command in the command line. Okay, and then I like this one. I test it, and then I take this line, and I paste it here. Or even better, I type directly here. My full script out of this, and then I come here, I save it, and then I come here and I run my script bash without even testing, especially when you know the command, there's no syntax error. So okay, if you want, you have several lines and you want to script here without executing this, you put the X. And this one is going to stop without continue. Okay. So this way you can test the first part, and then if you take it out, it's going to continue in the second part. Okay. So this is also very, very useful.
Maybe I have a related question. Like, how do we write different lines? Do we need to use an escape character, or can we just continue on the next line? when using bash, when using sh.
Yeah, here you can write any whatever line you want. So every time that you do enter, it's going to be a new line.
Okay, so no need of an
Okay.
escape character or any special thing.
Perfect. No skip character, nothing. If
Okay.
the line is too long and you want to break it,
Yeah.
Mhm.
for example, this one is too long, you put the backslash and you enter, but without space. Be careful. If you
Yeah.
put a space here, it's not going to work, and it also doesn't give you a strange syntax. So no space, and then you. So what does mean that all this line is the same? Okay. Okay, Valdez.
Yes, that makes it clear.
Okay.
And another maybe very simple question is, could you maybe go through the man file again, manual for any function?
Okay.
Because whenever I open, I spend too long trying to understand what are the different arguments
perfect.
available.
So what you are trying to test? To which command you are using?
I did the mistake of checking AWK, and it's very
Okay,
long.
AWK. Okay, be careful. AWK, yes, it's very long, but let's see what is given to you. Okay, so
Yeah.
first of all, you get also these other AWK, and I don't know what to say, but usually I never use it. It's this one.
Okay.
Okay, so then you have, you have some of them. Then you have some option, and once again, for all the bash option that are in square brackets means that are option. So you can skip. Okay.
Okay. Yeah.
Then whatever is not within, within square brackets means that is compulsory.
Mhm.
Okay. So then to keep pressing, you go below. So let's see the one that we've been using, also because I don't know all of them. So for example, we have been using this to pass a bash variable to AWK variable. And we have been using also this one to have separate column, identify the field separator between two columns. That as a default is space, okay? So once again, you can use it or not use it. You can press it like this, or if you want to search for something particular, you do backslash, no backslash, normal slash, and you type over here, for example, the word that you want. Print, there will be sure. Then you keep is selecting all the word print, and you keep progressing by pressing N, just the word N, the letter N. Okay.
Okay.
So you go and step for next, then when you read, you say, okay, I want to exit. You do Q, just the letter Q to exit.
Okay.
Okay.
Yeah, I missed the slash. That would definitely help a lot.
Yeah, the slash is very useful to search, especially when you know already the manual, and you more or less remember the word that is important. That one is the slash, and then you type the word that will be
Yes,
useful.
that's very helpful. Thank
Yeah,
you.
very good, very good. Okay, any other question? No. Okay. Okay, so let's start in our session in according to the syllabus. So if you go to the syllabus, we are going to have the lecture for PKTOOLS. Okay. So if you go scrolling down, you have PKTOOLS over here, and we will have two assignments for next week. We will see later what is going to consist. Okay, let's click over here in PKTOOLS. So let's do here and here. Okay, so for who was here in the first lecture, you had the honor to get familiar, or to know at least virtually Peter Kempners, that is the developer of PKTOOLS, that has been developing this tool from 20 years, close to 20 years, from when he was starting his PhD. And now he's migrating all the PKTOOLS in the C++, has been migrating to this PyGeo, that is an implementation of PKTOOLS inside Py. Okay, so he's going to talk about PyGeo, Peter, but I'm going to talk to the underline, to the master of the command that are born together with GDAL, really in the beginning of 20 years ago when GDAL was started. Okay. Most of the time, not most of the time, quite often, I would say, GDAL and PKTOOLS can do this, can do similar, not similar, the same, and even sometimes similar operation. Okay, so it's really depending in what you are getting faster in moving or using, let's say, using one or the other, or there are some other functions that are specific only available in PKTOOLS. Okay, before GDAL and PKTOOLS, they were completely separate. Okay, now they've been integrating not together but really close, in the sense that you can install the PKTOOLS directly with the command line. You do the typical apt install PKTOOLS and you get it. Okay, now pretty sure that if I do it, it's going to tell me PKTOOLS already installed. Okay, yeah, he will say that is already the newest version. Okay, so this is how you install it from scratch. Before install GDAL, if you have a fresh installation, before install GDAL and then PKTOOLS. Okay, they've been developing almost together. Maybe GDAL was starting maybe 1 or 2, 3 years before. Maybe then you can have better conversation with Peter, and Peter is probably also coming to Matera, so you will have also time to meet him in person. So over here, you can see there are a very deep documentation that has been growing in the last 10 years. In the beginning, I was the one banging him continuously for the improving the bugging these tools, and then creating the manual. Okay, and over here there are how to install it, installation. Okay, you have installation, how to install it, but that one is very easy with the apt. And then we have also the command. No so available tools. Yes. Okay, so over here you can see all the tools that have been developed under GDAL. So also in the terminal, like before, you were doing the same for GDAL. You do GDAL and then you press tab twice. It's going to list all the GDAL command. Okay, and then if you do the same PK, the PKTOOLS stay for processing kernel, and if you press it, it's going to list it all the command of PKTOOLS. Be careful that there are some that are not PKTOOLS, like pkcon. I don't think is a specific command for Linux, but you will see immediately that has not the typical help of the now we are going to see. Okay, so let's see the most common one. Okay, like pkcrop. Let's see some that are similar. pkcrop, as you can imagine, is going to be used to crop an image perfectly the same as GDAL translate does. Okay, so frankly speaking, I don't use so much because I use it always GDAL translate. So, okay, but feel free to use it. And frankly speaking, I don't know if this one has some particular difference that can be useful to test it. And there are quite a lot, so maybe there is something a bit more data line. Okay, maybe there is something slightly different from GDAL translate. Anyway, here you can see the typical syntax from Bash environment. So you have the command, whatever is compulsory, input and output. Be careful that this is one of the difference. Input and output are always identified with I and O, input, output. and then whatever is between square brackets, you have the typical, yes, syntax, the typical optional, okay, for bash. Here you have a quite good description, and then also something quite good that quite often are very quite dense. You have some exceptions that give you, of course, simple with one line, but is given to you. For example, this one is how you crop it for based on the coordinates, upper left, yes, on the coordinate of the file. Pay attention that he always use the same syntax. Also with GDAL, you can have all the compression algorithm that we will use, the -CO. You can use it also inside pkcrop. Look, for example, Martin was using the flag B for the band, identification of the band, so it's the same. So it's out of type byte, and you have perfect the same string over here for the byte, the same flagging for the byte, and so on and so on. So it's very similar to, and of course, all the input and output, they can be convertible and readable always from GDAL and PKTOOLS. The default is always GeoTIFF, but pay attention, because sometimes if you give an input to EMG, for example, also the output is going to be EMG. So sometimes it's happening also when you give VRT, automatically you think that it's going to be TIFF, but it's not. So it's good to, if it's GeoTIFF, you are not sure, just write the output type, and you will see that it's going to be GeoTIFF. Then there are some that are really for, there are some that are really for pre-processing of the image, like this one, pkcrop, okay? And there are some other that are really for post-processing, like, for example, classification of an image based on nearest neighbor, okay? Classification nearest neighbor. And for example, with all the explanation that Antonio is going to tell you about machine learning, you can even understand him better all the flags that are inside here. Okay, so because this one is very machine learning in neural network is really driven by tuning parameterization. If you don't do it correctly, it's not going to converge, and Antonio is going to spend a lot of time. There are some other that are really, for example, also this one for filter, yes, for artificial neural network, for identify the feature, I mean the sampling location. Then there is another one that is for filtering the Kalman filtering, and so some more advanced processing, okay? Field no data, for example, like the one that we see in GDAL, PK polygonize, like we have GDAL polygonize, but there are some unique, really unique, like PK set mask and PK get mask, that are really unique, and GDAL do not have this, and we are going to use a lot of this one. Something particular, you can always access to this help also in the manual, and actually we will use it quite a lot. PK, you do PK set mask -- help. Use always the -help, the double dash, because one dash is giving to you a short form, and actually I don't really use it. Actually, maybe a -h. Yeah. So the -h give you a short form, and I never use it because then I don't learn whatever is new, some more fancy stuff. And the same help that you find here, you can find also here without the example. Okay. Most of the all of the operation you can do I would say the compression, and quite often you can also referring to an external file for the processing of mask. We will spend a bit of time in this kind of application. PK composite also for doing the typical mosaic of composite. You will see a very huge implementation in the image in the lecture that we are going to use it to follow as an assignment, and so on. So there are, so for example, let's scrolling some ideas. Some of you, I saw that you were noted. You say, "Ah, good, I want to try that one." So maybe now you can see, okay, which one you were see or thinking, and maybe for some particular process, because with this one in GDAL, you can do 95% of the GIS operation you can do, okay? You cannot really do it something fancy like segmentation of an image or hydrological modeling like I do it, or, you know, something really very specific, not generic. But the generic one, you can do everything. So anyone want to say, can I do this? And we will try to see if it's available in GDAL or here. In the meantime, I open also the GDAL manual. And we want to the raster. No, I will. So anyone that is thinking something that he was doing last week in R or in ArcGIS or in other software, now they want to do it.
So I have a question.
Yes, please.
So you said it can't do like hydrological modeling, but can it do like the flow accumulation or the watershed delineation?
Perfect. So this is the stuff that cannot do.
Okay.
GDAL and PKTOOLS cannot do, for example, flow accumulation. So in that case, you need to enter inside GRASS.
Okay, grass.
But having inside GRASS, but having the advantage of knowing already the BASH environment and the GDAL environment for the preparation of the TIFF that you are going to use it inside GRASS is going to make your life much easier. Okay, because of course, if all the file has been really standardized in terms of size, pixel size, extent, and you import inside GRASS, then the GRASS is going to look really smooth, so you know, without any project problem or size extent problem and so on. So GRASS is also very good, but need to be, all the data set need to be prepared. Or it's much easier, let's say, to be prepared under GDAL and then entering GRASS just for the processing of the tools. And then you can combine GRASS and GDAL, you can combine all of them, PKTOOLS and so on. So it is a good starting. Okay, good point. Another question? Yes.
May I ask oh, sorry. Go first. Sorry. May I ask about the installing of both GDAL and the PKTOOLS? Is it git clone or sudo app? I'm a little bit confused about the two.
No, for both of them, you know, for both of them, the clone is only when you want to clone for a git clone, when you want to clone for a git repository. Okay. Most of these tools, they are already inside to the repository of Ubuntu. So if you are searching, for example, you can do apt cache search. So this is good for everybody. So type down, and you want to install it, GDAL. Okay, so it's going to search in all the repository where the package that has the word GDAL. Okay, if you enter, you will see many of them. Then at this point, for example, the one that is going to install GDAL, you do apt cache, install GDAL bin. And this one is going to enter and you install it, okay? Of course, there are some other, sometimes it's a big, you don't know which one to do it. It's not a big deal, even if you install it something that you're not going to use it. Most of the time, they don't give you problem. But for example, if you want to, so if you do GDAL bin, you have to do also this one, the Python GDAL, where it is. Yeah, Python 3 GDAL, this one. I should check this. This one, a Python 3 GDAL, because this one is going to install it, you know, GDAL edit, GDAL, the one that was with
Python
with
code.
the one that we're using with the .py. Okay,
.py.
this one, and so on. Okay, because these are including in this package. Okay, and the same for PKTOOLS. This is going to be installed immediately.
Okay.
Okay,
So we don't have to git clone again. Git
no,
clone
no, git clone in our case just for the data, for the data set. Okay, just
Okay.
for downloading the data set, the SE data that we are using.
Okay, thank you very much.
Okay.
Okay.
Good. So yes, anyone?
So I was going to ask, speaking of extent projection and what's it called? Extent projection and resolution. I know there's a command, there's an R function that one could use to compare, to check if multiple raster files have the same extent projection and resolution. So is there a command like that for GDAL and PKTOOLS?
Not really, but for example, if you have, you know, yeah, let's go LS data exercise. Yeah, let's use the typical one, this one. So this can be a small example that can be useful to see the difference. For example, there is one that is called K-info, PK-info, and that is given to you. For example, you want to see the extent -I. So this one is giving to you the extent, okay, of this file. And of course, you can create a for loop and having all the extent of the file. Okay, so we can do faster for file in Control K is cut all the line and Control Y is pasting back. Why I'm doing this? Because in this way I can be fast and do it tac. For file in all my diff, do pk $file. $file done. Okay, so this one forgot to do. This one is giving to you all, you know, all the file, and this actually is better in this case of GDAL translate, because in GDAL translate you have to do a grep function to get only the line of the resolution. Okay, so there is not a real command. We were say before pkdiff, but this one is giving different pixel level. I don't think that giving different at resolution level. Okay, but you can try. No, I don't think so. It's going to do a pixel level. And then there was another one inside GDAL that was GDAL compare or something. This one, frankly speaking, I never use it. So it's good to test it. GDAL golden new file. Yeah, maybe it's giving to you is giving to you the difference, GDAL compare. I don't know if it's doing it at pixel level or.
It seems like it only accepts 2 files.
Yeah, I don't know what is giving this golden. What does it mean?
Maybe like the gold standard, sort of.
Yeah, I don't know.
Like
I
that.
never. I don't know. I never read it. I never use it. So usually I always do a for loop that is checking if all my file have the same extent and the same pixel resolution. Okay, and with the PK info is a bit easier because it gives you don't need to grab. You know, you can see in the manual can give you also. I think the TR giving to you the resolution. No, probably not TR. Anyway, you can check which one is giving to you the resolution. And then eventually, if this one is really, you know, too long, you can sort it, or you can do a graph to see if someone is different. So this is the kind of application. Okay, so let's do another one, another. Thanks, Olatin. Another question concerning this. Can I do this with geographical? And I could try. Anyone? Something that you were doing last week. Come on, in ArcGIS.
Maybe you said there's a masking
Bravo.
option for, so
Okay.
if I have a Sentinel scene, can I do cloud masking because they have this
Perfect. Very good, Carol. Yeah. So that
control?
one
Yeah.
is a nice question, and actually this one is not possible inside GDAL, and we are going to see two PK set masks and PK actually before PK get mask and PK set. And it's better to do it in the exercise as soon as we reach. Actually, let's jump immediately there. So if we click over here, you can arrive, you click in the raster tool, you can arrive directly here. Okay, you have this lecture, you have also the lecture for last year in case you want to see. Once again, this one is again, please check it. You use it with Jupyter Notebook. No, let me close something here. No. Yeah. So you enter in the user director exercise and then you open the Jupyter Notebook, the PKTOOLS SJ. So Jupyter Notebook. Okay. So I'm going to scrolling down. You can feel free to use the Jupyter Notebook or the. So they are written in C++ and they are extremely fast. Okay, so we'll see how fast they are also in terms of computation. Once again, I'm using small data set, but even when you do it in a large data set, in a larger TIFF, and as I mentioned before, never try to pass the 1 giga file TIFF, you know, one and something, because then it's becoming really complex, you know. And also remember the GeoTIFF has a limitation that is 4 giga. So if you overpass in this 4 giga, you have to put an option, inserting an option in GDAL that is big TIFF equal yes. But this one is giving you a warning. So you will see in the terminal. So, but keep in mind that this one is a limitation in GeoTIFF. Okay, last time, if you remember, we were seeing how to convert a TIFF file to a X file, to a text file, not X file, to a text file. Okay. Okay. So last time I was getting this file, if you remember. Geodata vegetation, and then ETM. Okay, we were creating the text file, the crop.txt. So this crop.txt, if you remember, this is the file that I just created now, so you can see that it's 13. It has the typical X and Y coordinate with the value of my X file. And then we were using AWK to change all my value that have bigger than 2 and less than 4. Okay. So, and then if we were doing the same and getting my output file, we could see that I was creating a TIFF file crop underscore if I was creating my T file that have all my pixel that were inside to this trend in this between 2 and 4 become 50. Okay, so you will remember, I think you remember this kind of operation. So all this file, you can see the white one over here, they are 15 value because we were doing the inside to this operation. So now this one is becoming how you get the mask, how you change the pixel value inside the image based on some condition, and the condition were expressed in, say, inside the application. So I'm presenting this because if you remember when I was explaining, I say, be careful because this is a good way to know, but it's not efficient because we are going in the production of TXT file. That is something that should, from a computation perspective, you should always avoid because it's very slow. Then if you want to do it because there is no solution, because you are testing, you want to see, of course you can do it. Okay, can we do it the same kind of operation? So in other words, selecting some pixel range and do it inside an image and create another image without going through the TXT file? Yes, we can do it with the PKTOOLS. So now let me make this longer. This way I think it's easier than okay, so over here we have the so-called PK. Be careful about this PK mask. PK get the mask and PK set the mask. So PK get mask, you can read also PK make the mask to create the mask, and the set mask to apply the masking to another image. I hope that the masking concept in people for GIS and remote sensing is quite straight, but in few words, it's nothing else. I have an image, and I have another image that has some specific no data and some value, no data, some value I want to put on top, and whatever is below become a certain value. Okay, so this is the masking operation. So Carol will say, okay, for example, MODIS dataset, MODIS and Landsat, they have the so-called mask band. That is a band that goes, actually it's not 0.1, but it's 0.4 if I remember correctly, and give you different quality of the cloud, let's say. So there is the value number 4 that is 100% cloud, something like this. Okay, can I use the value 4 and apply to this value to another image in order to get rid of all these pixels? Okay, not to get rid of because you don't cancel the pixel, but you label it with some particular value. Okay, so these operations are made in 2 steps. First, you create a mask with PK set mask, and second, you apply the masking to some other. Okay, so let's see how it goes. Okay, and I'm going to give you 3 examples of the command that are doing perfectly the same, but changing the value. And why I'm doing this? Because I want to show you that is a very flexible tool. Doesn't create a mask that has value 0. No, you can do a mask with value 25. Okay, you can do any kind of masking with a pixel value that you want to decide, with a range that you want to, you can decide. So that's why you have extreme flexibility, something that sometimes GDAL is a bit tight on this. Okay, so you have the typical compression. Okay, then let's jump it over here immediately. You have the input file with I that I'm going to use the same image, and then over here you have the output identified with O. Perfect. So this one you already know. It's going to be the output is going to be my byte in data type. Okay, so now we go inside to this image. Let's open the image, and this way we can see. I'm going to use the crop key. Okay, so I have this image over here, and my pixel value, they go from different values. You can see that they are changing. Okay, over here. So now I'm going to create From this image, I'm going to get all the pixels that are between 1 and 2, and in my output, it will become 1, be careful about this, 1 inside my range, and 0 inside my output of the range. Okay? And we can also see the manual later on. So the same concept is also on this one, but changing the range and creating three masks. And now I will tell you why. And also here I can say the same, you know, but here I do the opposite. Okay, this is why, because I want to have flexibility in showing that I can create whatever masking I want. Okay, so in this case I will have 3 masks, one with the 1 0, the other one with 1 0 again, and this one is going to be the opposite, 0 and 1. You can change as you want, extremely flexible. So when you create this mask and you can see the output, they are going to be A, B, and C. Okay, so we can open. This one is also mentioned already. Control / is killing everything that you open. So now you can open the same image. The TRH. No, yes, no. So I'm going to create the input and the output. Okay, it's giving me the error because so over here you can see that you have the 2 files. One is going to be 0, 1, and the other one is going to be my input image. So let's see first the input image. So the input image is this one. You can see the one that I opened before. Okay, a bit wider. And this one is going to be my, be careful because here it's 0, 1, so you don't see, you need to do some stretching. So everything that was between the range become 1. So everything is here become 1. And then outside to the range becomes 0. Okay, so I did different ones for any kind of range. So I obtained 3 of them. Okay, so now let's suppose that one of these is, for example, the cloud that Carola was mentioned. How can use this image to my image to mask out all the image. So let's see. You can do it with the PK set mask. Okay. So rather than having the cloud, we also have one mask that represents the water, another one that represents the city, and we are interested only in the forest. How we can do it? Using the mask that I was creating, in particular, where is my, so these are the 3 masks that I was creating. Where is 1, where is the value 1 in my mask data become -9. The kind of B becomes 5, the number C become -10. Why I put 10 different numbers? For example, if I want to keep if I put the same number, everything becomes the same value, so I will not be able to track it. Rather I say, okay, let me put all negative numbers that in my image there are no negative numbers. In this way, I know that -9 is water, 5 is cloud, and 10 is city. Okay. Now, if I run this one, what I'm obtaining, I'm going to see the mask, and usually I always use it in this terminology, MSK, and you can see MSK, the MSK stands for mask, and you can see that my masking, I can again make it larger in this way. So you have your input value, this one, okay? Your input value, this one is the input value. And now I have my masking that has, you know, different in the different area that I was using to mask, look, over here I have -10, over here again -10, but somewhere here, for example, I have -5, and somewhere else I have the other one, -9, okay? And all the rest are perfectly the same. In other words, I'm using one image that I was creating that has a value 0, 1 to be applied and mask it, use it, and apporting a one specific pixel value that allow me to identify later on if it was cloud, water, and so on. I could put it again. I did it different value to give you the flexibility. But once again, this one can be the same. I put different because I want to identify that there are no data, okay, fine, but are important to identify between the two. The beauty is that, as you can see, I can put many of them, okay? And once again, this line, okay, using the mask for the different operation, you are going to see in most of the PKTOOLS. So every time, for example, the other day we were doing the multiplication. Okay, do the multiplication of the pixel, but inside to this, it's under this masking of mask raster, don't do it, and apply this now. So this is the concept of this one. So, okay, and once again, this one we will see in PK composite, for example, is very well used, this one. And in some models, there is always this M that you can use it to apply. But of course, before you have to create it. Okay, so you have to create with the PK get mask. Of course, if you have one image that is already 0, 1 or is already a class, you know, if you have already, because here I created, but over here it can be even land cover where I put forest, my forest value become -9. Okay, if I'm interested in the agriculture. Okay, so if I use it, this one PK set mask because it was a floating point, but if it's an integer map, integer raster file, you can use it immediately. Okay. And probably we can see immediately the implementation inside to this composite of the data. Okay, but before to go here, any question about this concept? And be careful about these that could be tricky to read the manual, because if you do PK get mask, I mean, if you know the concept, and it's quite straight, because you have, you know, you have over here the manual. You have the minimum maximum that you set, then you say data value for the valid pixel between minimum and maximum, so inside to the range, and then the no data is outside to the range. So you can thresholding a continuous map, a continuous raster, okay? And then when you do the set mask, you have the same terminology. You say no data value to put in the image. So so in this map, my value 999, the typical, are becoming 999 in my input. You put over here no data -199. Okay, quite often you can use it also at some other value that are yes, that are commonly used. I don't use so much the -99. I use it, but not always, for a simple reason, because sometimes it's very far away from my value, and then the OpenEV doesn't stretch it and all the stuff. So, for example, if my value are all positive, I use it just -1 or -2. This way, even if I get the coloring of that, you know, data value is not stretching everything. So it's good always to work with some other value as a no data value. Okay.
I have a question in the same help file. Over here, how do you know mask no data and mask band have to be given together after the M, after providing the mask?
Okay, good point. So over here, mask no data, mask value where image has no data. This one actually is referring to the mask value. So this one is linked to this. Okay. Rather, this one is only reading, is only giving to the labeling of the output data. As
Okay.
Okay. Okay. Good point.
What's the output?
Mask no data.
But how do you know that they
Yes.
need to come one after the other? Because in your script,
Yeah,
you're giving them one after the other, right?
Yeah, mask. Okay, first of all, this one can be changed the order.
Okay.
All the bash command, the GDAL command, you can invert the position of the flag. I always try to have a logical sense, and I read it this way. I have my image. Whatever in my image is 1 will become in my output -9. Okay. And so on for the order.
But it still needs to understand that 1 and -9 is for this mask file.
Yeah, so this one is for this. It doesn't matter the position, it matters the labeling. This is actually for the output, and this one, sorry, this is for the masking, and this one is going to be the output value in my output diff. Okay, is it clear?
I understood that part, but I'm still
Okay.
not very clear on like in the help file, how do you get the clue that you need the mask to no data and you need the no data value, and it needs to be after the mask
Okay,
file.
because yeah, you have some default. Sometimes, actually also here, you have some default. So if mask no data, you don't specify anything, it's going to be 1. And the no data, if you don't specify anything, is going to be 0. Quite often you have some default, but even say if there is some default, I always try to put it in this way. It's easier to remember also, to reread the scripting procedure. Okay. Did that reflect the question?
Yeah,
Yeah.
that is not a must, but you can use it, and it's good to keep it in order.
Perfect. Yeah.
Makes sense. Thank you.
Welcome.
I also have a question.
Yes, please.
For example, if I want to assign value to a raster not based on the original value, but based on some sort of delineation, and like
based on what?
Based on some XY coordinates, like a delineation of, for example, this part of the image will be 1, and then the other part will be 0.
No.
Okay.
No, that one is not possible. But you know, you can. Yes, you can create a raster file that has, for example, even the lat log. You can create a raster file that has latitude gradient. Okay, and then you use that one. If it's less than 2 degrees, becomes 0. And actually, good points. This one we say equal. Here is there is one flag that is the dash p, the operator that is the flag is equal. Okay, equal to p equal. You put the parentheses. So what does it mean? If my mask is equal to 1, I say equal to 1, put 99. If my mask value is equal to 1, put 1. Actually, sometimes even better to put here. No, here. If, but you can also do it in this way, less than. Okay. So this one you do less than, and you say if my mask data is less than 1, put 5. This one is again pixel value, is not location. But if it's a location, you can create a raster with that location pattern, let's say, if you have a polygon. And then that polygon will become your delineation pattern. Okay. So it's possible, you have to do in 2-3 steps, but it's possible. Okay.
Yeah. Well, that's like my thought, but I just thought maybe there's an easier way to do it.
No, with the location, not really. You have to first create.
Yeah.
Okay, first create a raster, or maybe cropping another raster based on one particular look, let's say lat long, and then use it. Okay.
Yeah. Thank you.
Okay. It's coming clear a bit, you know. So
do
yeah.
these mask rasters have to have the same size as my data, or could they be?
Yes and no. Yes and no. Most of the time, as I mentioned, it's better that they have all the same extent and all the same pixel resolution. Okay. So if they don't have it, sometimes you have a warning. Actually, PKTOOLS doesn't give a warning. You have a segmentation fault without any error. So so it's better to have always a file with the same extent. You can even fake, you know, if you have a small raster, okay, for Europe, and you want to use that raster for Europe for the full globe, what you do a VRT with a full globe dimension, ingesting and having inside the full raster. And then you use the VRT inside the gate set mask. That's why the VRT is very compatible with this one. Quite often they work. So you have to try, let's say, and see if it works and you get what you want. Okay, very good question.
So, and then to tag along the previous question, so let's say I do want to mask along a polygon file, a shape file. Would I have to first rasterize that shape file?
Perfect.
And then
you first rasterize.
Yeah.
You first rasterize, and actually is even better, because in that case you are sure that, you know, also during the rasterization you can decide how you want to rasterize, including all the pixel or the pixel including the polygon, you know. You can do different kind of rasterization, and during the GDAL rasterize or even the PK rasterizer also, you can define if you want to include it or not include it. You can define the pixel resolution. So it's a bit better to having it two-step, because you can control it better. Rather, if they do it in automatically, then you don't know how they are going to be used, the rasterization. Okay.
Mm-hmm. And then in rasterize, can I specify, like, he rasterized this polygon file, but use the extents and the resolution of this other raster file, or do I have to like specify that manually?
Yeah, in the GDAL rasterizer, you can specify the pixel resolution here with the TR, and you can even the extension.
Oh, the extents there.
Even the extension. So, for example, if you know that you are going to use a global level, you already rasterize at that size. You know, is always trying. And then here is the one that I was mentioned. This one, auto vector raster. This one together. Even together with the pixel resolution, you know, because you can, you know, also, if you have a PK set mask that is 1 kilometer resolution, you have a mask of 1 kilometer resolution, and you have a file 100 meter resolution that you want to mask, the mask is going to match very well the 10 by 10, you know, so it's always same resolution, or at least some resolution that is a multiple of, you know, like 10 by 10. So it's also easy to understand what is going on if you want to see the result or not. Okay, very good. Let's see this example in the PK set mask that you will appreciate the function in this. So, for example, let's we have the typical our map. Okay, we have the typical file, the LST file that we will open over time. Let's see, LST. Yes, this one. So I have this one, and I want to do the typical masking. So it's not a cloud. as Carla was asking, but it was water, let's say, but it's pretty the same. So I have my mask. I have my file, and I know that this area is water. Okay, I'm going to create a mask having this area equal to a number. What I do? Okay, I want to use the old one. So I come to the image, I get the pixel value over here, and they say, okay, let me create a mask first. And this one, I do it with the first, getting only 1 month, and say between 0 and 25, put data equal to 0, no data equal to 1. So now I will have a binary map that I can open. So I will have a binary map that is calling, I was calling month 1 mask. So I'm going to output the same one. And the mask attachment. Okay. So now I have my masking. This is the original one. So then I have my, sorry, this one is the original. Then I have, again, careful because 0, 1 is not stretching. So all this area that I was using, I'm going to mask it in all my image. Okay, let's see how I'm going to do. So remember this, keep in your mind this pattern, and then we will see how it's used. And remember, inside is 0 and outside is 1. Okay, so we are going to see how we are going to use this 0 and what to do with this mask. So now we create a mask 0, 1. Now what I'm going to do, I'm going to create a composite. And that composite, there are two kind of there are two words to say composite and merging. Quite often, okay, it's quite often they're used as a synonymous, but they are not really as a, the composite is usually when you have overlapping between different tiles, okay? Rather than merging is like when you don't have overlapping between the tiles, but sometimes they can be used in different. So I have all this file, all my months that I want to merging all of them, composite, and among all the value, I want to get the mean. But how? I want to do it everywhere, but not in my mask location where my mask no data is equal to 0, put destination data 0. Okay, so again, I have my 12 value, 12 months. I want to do a mean between all the pixels, but under this pattern of my mask, I don't want to do it. I want to have just. Okay, so and then I can do perfect the same if I do the standard image with the standard image. So let's run this one. So this is doing the composite again between these. Now all my file are I have the same extent, but if they will be like this, typical modis image that they have overlapping of pattern of stripes, you can do it. So the advantage of PK composite, and that's why it's used for the satellite, he was using for the satellite composite. And for modis and Landsat is the best of the best. And in particular, because this one can be your cloud band. Okay, your cloud band. In particular, there is one flag that you put mask band. And we need to see how it looks. Mask band or something like this equal to, I think it usually is the 8 of the mask band. So it's going to use it directly from the image, the band number 8, to use it as a mask. Okay, so so let's see the output of this, and then we can try to see if there is any doubt. So mask mount, standard deviation. Okay, I open the standard deviation. So look, I think you can immediately see the same pattern of the mask over here, So there's been calculated the standard deviation everywhere, but not here where, and what I give it to here, -1. Let's see, why is -1? Let's see, because, you know, the standard deviation can be 0 if all the values are correct. So in order to be recognized later on, I give -1, because the standard deviation cannot be 0. Rather, this one, the mean and all my value were bigger than 20, so the mean is. So these are our flexible clues, okay? And this is going to be, again, this one was applied to all the area that was labeled as a mask in my input mask. Okay, so this one is not possible in GDAL, not at all. Okay, so this is the beauty of combining these tools together. Okay, the same operation you can do it with PK stack profile, so you can do it the same. You can create the build VRT, so merging all, not merging, but make a unique piling stack file, and then creating the mean and the standard deviation. The advantage or the difference between these and these is that, you know, with the PK static profile, you can do with one pass, so you can calculate both mean and standard deviation. Okay. The difference is the PK static profile, the image has to be perfectly the same, okay, in terms of resolution size. Rather, PK composite, no, it can be even like this, okay? And what is going to happen that where you have two values, you will get the mean. Where you have only one, you are going to have only that value, okay? So imagine the typical Landsat and embodies example, okay? So anyone is already thinking how to use in his computation. These are very, very powerful. I mean, this PK composite, I use it, and you will see next lecture is a very full use of this PK composite, especially for people working in satellite image. Okay. Valdrich, are you really thinking how to use it?
I work a lot with modeling data, so not too much with satellite image. But I have a question about a previous function that you were using, the
Yeah.
set mask. Over there, how does it handle conflicts? Supposing we are interested in algal blooms, and we have NDVI as a mask for plants versus not, and we have another one for clouds, for water. Then how can we use conflict? How can we manage conflicts over there?
I mean, over there is really depending from the raster range, the pixel value range that your NDVI goes from -1 to +1. If you want to create a mask, you know, you will give a value -3 and then apply the value to the output -3, because you know that an NDVI cannot be -3. So it's really depending how you want to use it, you know.
But if we have two
Yeah.
masks, let's say one for clouds and another mask for for plants, for
Perfect. So over here,
then
you
how?
can specify each single value. You know, here you can see that the output is not all the output in the mask. Over here, we'll just put -1. Okay, but here I can put different -9, -5, -10. Of course, if I put -9, they will go in conflict because the two masks will give me the same output, the same output pixel value.
Yeah.
But if I put something different, I can always track it back which one is which. Okay. And then giving, for example, giving to you a bit of flexibility in your modeling, but how you do the ensembling by this, by PK composite, because you get all your 100 iteration as a raster file, and then you do the mean and the standard deviation of the 100 iteration. So this is how I always do because in R, if each processor is giving to me a TIFF, you know, I have to hold in back all my TIFF inside my R or Python, and then rather each single iteration give me a TIFF, and then I use PK composite, or even better, PK start profile to get mean and standard deviation, and I have my ensemble model. Okay, so there is always a good way to use it, these tools.
That seems a good idea.
Yeah.
May I ask
Yes,
about the, sorry, Giuseppe, may I ask about the, on the above, there's the P and then the equal sign. The default is the equal, right? The
Perfect, bravo. Yeah, so the default is equal here, and actually I didn't put before, but of course you can use mine, bigger or less or larger.
anything
Okay.
smaller than 1 will become -5 here. Anything.
Perfect. Everything be smaller than 1 will become negative. Yes. So in my case, everything between 0 and 1, for example, because 0 they were not negative, would become
Is this anything more than 1, or is it anything less than 1? Here, what does this mean?
Less than 1. Less than
so
1.
This is anything that's less than 1 will become -5, right?
Yes. If I want to, of course, if I want to less equal, I have to put 0.9999999 because there is not the less equal.
Okay. Yeah. Okay. Thank you very much. Thank you.
Actually, the opposite. The dot to 0. If I want to include a 1, I have to do that. Yeah. Yeah. Somebody will say something.
Yes, and is it possible to combine some conditions here, for example, to mask values which are less than some number and that are simultaneously more larger than some other values? So, for example, to combine this,
you can repeat the same. I think I understood correctly. You can repeat the same mask and giving another value. You know, you want the equal to 1, but also, I don't know, larger than 1. Actually, this one you will include the 1. Yeah, so this one will give you equal to 1, and this one will give you everything that is less than 1. So you can combine. You have to thinking how to combine, but usually is for one mask, one value. So let's say this one. Let's say this example that this one is even better. That this one is helping you to see the flexibility. So this is my input. What I'm doing here. First, there is the output. Can you see? Oh, sorry, this one is. Anyone? What is this?
The input file.
This is the input file that goes from whatever number to whatever. And then I use as a mask himself. So everything that is going to be less than 1 is going to become -9. Okay. So I use the mask to himself to mask out every value that is that one. This is the typical example it was mentioned about the NDVI stuff. If NDVI, you know, water is what? -1. All right, yes, I think I remember something. If a mask is -1, I mean water is, let's say, less than -9, less than -0.09. I use himself. So if I want water, and this is my NDVI, I do 0.9, 0.9 become water, -9, 0.9. Okay, so I can use also to himself to create a thresholding one raster and say whatever is less than this value, put another number. Okay, this one is extremely useful. And this one, remember, they go together, PK composite image together with PK stack profile. They are slightly different. They can do similar stuff, but they're slightly different. Composite is dealing with different alignment of the image. That's why composite, rather PK stack profile, they need to be perfect the same. And also remember, the composite is also can deal also with the different pixel resolution. Now, what is doing over there is a bit tricky because, of course, you don't know the mean, and also if they are not aligned in perfect. So he's dealing with this one, but let's say if this one are my pixel, is able to deal if it's like this very well. But if it's like this, the pixel are not aligned, you don't know what is going on, which pixel is getting. So it's better to have, all of them aligned at digital level, degree level, and then able to deal with stuff. Usually, if you download Landsat, they have already taken care of this, so you have alignment in the pixel. So it's very good to use this kind of operation. Okay.
If I have a different mask for every one of my images, so let's say the clouds, right? So I want the mean NDVI over a year, and each image has its own mask. Do I have to do it in 2 steps, or can I do it in one in the PKTOOLS? Like, of course, I can mask it beforehand. Yeah.
You can do all together. Good question. I think, this one, okay, need to be tested, but this one can be a VRT file that unify all the masking band, and then you will give only one file.
Mm-hmm.
So, but need to be tested.
Yeah, so I would use a VRT as input and the mask VRT as in.
Yeah, that one could be your VRT file that has not as a separate, but as a VRT all the band. Yeah, could be that one a good solution. Or maybe not, because if you have overlapping area, that one can work if you don't have overlapping. But if you have overlapping area, you want to be sure that each mask is taking care of each image. Okay, because of course the cloud can move. So probably would be better to have, one input, one mask, one input, one mask, one input, one mask. Okay. But in the PK composite, I think there is something that already taking care of all this, and we can see. I think I use it in my script that I think is going to be lecture. Band no date and destination no date. Yeah, need to be tested, but I think it's possible if you give the same band. Anyway, it's possible. You need to just be sure that how you think, because sometimes you don't get the syntax error, but then it's not the same wave that the developer Peter was thinking when he developed. So it's always good to testing what you get as an answer. Okay. Okay, perfect. Let's have a break, and then we start with the filtering. So we come back at 00. Yes. So we have 24 minutes of it. No. Okay. No, didn't share it. Okay, so now we are going to have another kind of operation that is quite common in the Rust environment, that is so-called filtering or aggregation. Okay, filtering, we use the word filtering when we have the typical moving window filtering and the pixel dimension doesn't change. Okay, so you have a filter 3 by 3 3 by 3, so 9 pixel, and you want a 9 pixel become the mean value, calculate the mean value and apply to the central pixel with a focal cell to the center. And this one is the typical filter aggregation. Sorry, filtering operation. Rather, the aggregation is when you have again a moving windows analysis, but you have a downsampling, upsampling of the pixel resolution. So you can go down or up. Usually aggregate means to go from 100 meter to 1 kilometer. So you have the typical 10 by 10 moving window, and you can calculate it. This operation can be done both of them with the function PK filter. Okay, be careful that the tricks stay in identify if you want a filter or an aggregation by using the option, the flag D. Okay, so let's see this one. So I wanted a typical 10 by 10 aggregation, so 100 meter become 1 kilometer using aggregated with the value of 10. Okay, and inside to the 10, they also call it block moving window, block window. You calculate it. And of course, among this one, you can see there are plenty of them. Okay, you can see in the helping image, PK filter, Okay, you have the dash resampling method. Okay, you can identify the resampling method, but you can identify also the mean over here, the F. Look, you have many of them, mean, varying, minimum, maximum, mean, and then you have also some kind of specific filtering, like eroding, closing, opening, homogeneity, count ID. Somebody was asking about counting pixel number, over here, mode, smoothness of the data, and even something very complex about wavelet filtering. Okay, so we will see an application of this one. And once again, the dash D identifying the downsampling factor. Okay, so in particular, in the example, you can see that this one creates an image that is more blurry because it's been aggregated by 10 by 10. Rather, this one does a moving window of 11 by 11 and calculate the mean, but there is no 10 by the 10 downsampling. So what does mean? That the pixel resolution remains the same. Okay. Something also quite cool is the option C, that you can have a circular moving window. Rather than having a block, you have a circle. And especially when it's bigger than 3, is 11 by 11, it's becoming really important to have a circle because the diagonal is very different from the radius of the circle. So you can see, you can run these two, and you can see immediately so and now I'm going to even tell you when so you can see in the same image that one was in the last week. Okay, so I'm creating this circular mean. Okay, as you can see immediately that this one is smaller in size because it's becoming 10 by 10 pixel, and this one is much more actually pretty the same. It will be the same size of the previous because it doesn't change the yes, because I didn't change it. Okay, So you can see that this one has the pixel size, and you can see immediately that the pixel size change between the two, okay? So the filtering can be used for something very specific, like, for example, age detection between forest and agriculture, or can be something really specific. I use it quite a lot, frankly speaking. And this one together also with the digital translate one, I'm working a lot at 90 meters. So if I want to see a global implementation, I cannot open the 90 meter global level. So I immediately do 1 kilometer. And to see the error, what they do it, I calculate, for example, the downsampling with 10, and I get the minimum or the max. In this way, I get the extreme value of in the pixel what is happening, you know, because if I get the mean and there is only 1 pixel, probably I am not going to see. Rather, if I get the minimum or the maximum, I can then visualize the global implementation, and I can see immediately something. Not always, but quite often you can see if something is wrong or not. Or you can do several operations, okay? So this one, also this one, I think, I'm not sure, but we can double check again if allow the masking operation during the filtering. Let's see. Maybe not this one. But of course you can, no, this one does not allow any masking, but of course you can, sometimes you can do the filtering and you mask later. I mean, you do the filtering also where you don't want to filter, and then you apply later on a mask. Okay, give me the previous value before that. So some can be done even after the computation. Okay, so this one is very good also because with this, okay, this one identify we see in the dimension. The dimension over here, look, yeah, so this one identifies the dimension in the X and Y direction of the pixel, but you can also do what? The DZ. So this one is is the time frame, so the band filter. So in other words, you can even do a cube 3 by 3 by 3 filter, okay? And you can do also filtering only in the zeta dimension. If you put 1, 1, 3, what does it mean? That in the spatial doesn't give you anything. If you put something like this, 1, 1, okay, and dx3, what does it mean? That you have 3 bands. In the spatial doesn't make any interpolation, but in the spatial, it becomes a mean of the 3 bands, okay? And this is very good because when you do the data cube operation, this is how I do it in the multi-dimensional interpolation with this kind of filter. And of course, over here, you can calculate the max, and if you want the temperature of the max, a moving window, for example, typical moving window analysis in a satellite image or in the temperature. So this one would be the typical moving window analysis between 3 bands. And of course, if you build up a for loop, you can do the 3 bands, and then you shift of 1 band, and you do another 3 bands. Let's call it days. You do 3 days, then you move 1 more, you do another 3 days, and then 1 more, another 3, and this is the moving windows. You know what I mean? So you can really build up whatever you want in this temporal, spatial, let's say spatial analysis in terms of filtering, the moving window filter.
But I wouldn't need a for loop for that, no? I thought that's what PK filter does, right? If I say my temporal window is 3, then it does day 1 to 3, then day 2 to 4, 3 to, and so on, no?
No, you have to build up a for loop, okay? And because you have to get the first 3, and then from 2 to the 4, from 3 to the 4, and so on. So you have to move inside to the temporal dimension.
Okay.
Anyway, with all this one, they will be very well implemented in the next lecture that you are going to follow with a video. So it's going to be very exhaustive in this kind of interpolation, temporal interpolation technique.
So in that case, what's the difference then to PK composite? Like if we just in the time dimension.
Yeah, good point. It will be the same.
Okay.
You're right. It will be the same. If you have 3 bands, perfect the same, and you get a temporal mean, will be the same. Okay. Remember always that between all the tools, PK composite is the slowest one for a simple reason, because it has to match if all the image are not in the same alignment and so on.
Yes.
Rather, this one, they always think, and yeah, and they should be, always pixel in the same alignment. So this one will be much faster than PK composite, okay? But good point. You can do also moving filter even with PK start profile. Actually, probably we'll do it with the PK start profile. But over here, you can play the dimension that you do the 3x3 and you have the cube. So with this one, you can do it. In the PK start profile, you cannot do cube operation. The spatial operation you cannot.
Would this work for virtual raster as well? Like
yes,
to have the
good point.
dimensions.
Yes, yeah. So rather than if you have a single TIFF, you can create VRT point, VRT file with 3 bands, make a moving window of that one, and then shift to one another VRT and so on. So yes, good point. Most of the time it works, okay, the VRT. There are some specific case that you will get some errors, or you say, okay, let me create a TIFF. And then if the TIFF with the TIFF works, then avoid the VRT. But always give a try with the VRT, because in terms of size, it's much more efficient. Okay. Something also extremely useful that I use it quite a lot is the function for PK stat histogram. Okay. So this one is giving to me the histogram of a file where the first value give to me the value of the pixel, and over here how many file I get. Okay, so if you do let me do it here. I run first and then. So if I do it over here, I can create a file. Okay, so if I do this one, geodata temperature, geodata. And now. Okay, so for example, here I created this file that I always call East. Once again, that one is just a text file. And over here, I have all my file where I have from the starting point, that is the first 0 value, until the end. And over here, be careful that it's always giving to you also that these value, there are no pixels, 0 pixel. But if you go down, you can see that you have you have 168 pixel with the value 93. Okay, so be careful that is also printing if there are no pixel with the value 0. Okay, so but this one is quite straight that you can do the graph function, and you can avoid to print the dash v space 0. So you avoid all this one with the 0, because and now you can see that your pixel, they go from 61 to 93, and this is the typical. So you can see immediately, for example, is this image normal distributed or not? You can see immediately. So this is very normal distributed. You can see the pixels become bigger in the okay, they are not skewed to the left or skewed to the right. Of course, then you have to do some statistical analysis, but you can give immediately an overview that this image is normally distributed. So the histogram is very good to do this kind of analysis. And of course, if you do, if you have the TIFF file, these are nothing else. These 61 and 93 are nothing else than the minimum maximum. Okay, so if you do minimum maximum, you get 69, 93, but you can see that you have only 2 pixels, for example, at the 61. So these are very good. The histogram is also very good to identify outliers. for example, in the raster file, because you can have a minimum maximum value extremely high, but maybe just 1 pixel. Okay, so I use it quite a lot. And if you open the image quite often, you can't open because it's big. Or also, there are many images, so you can get the histogram and check the histogram of all the image, and you can see the minimum maximum. And you can identify some outliers, some particular stuff. So pay attention that if you have integer value, then you have a very well structured histogram like this one. But if you do it to a floating point, you get, you get a range, you get a identification, and you can set up the minimum maximum if you want to avoid some particular, I want the histogram just between 70 and 80 for some reason. So over here, you can set up the minimum maximum at 0 and the maximum also. Okay, and you can also identify the bin. How many bin, so how many line you want. So you want 100. Here, of course, is going to be longer, and each single class will have less value. Okay, so expected that if it is an integer, you are going to have integer value, rather if it's a floating point, you're going to have, from here to here, you have 495 pixels, and so on. So it's very, so you have, very important, for example, in my case, that I do hydrological modeling and dealing with a lot of basin ID. How many basin ID I have in my image? So how many polygon ID? I do like this one, and I can get how many I have. Okay, so this is where it's really, really, really efficient to work with the histogram. And you have also in GDAL Translate, the function histogram that is somewhere in one, but it's very ugly. That you cannot, is in a string like this. You don't see other 2 columns. You cannot identify the bin. You cannot set minimum maximum. So I tested once and never went back to use it. So, but I use it quite a lot, especially for data processing, or also, like I mentioned, for data checking, for see what is going on in my computation. And something also extremely useful in the use of histogram, that you can use it also to reclassify an image. Okay, so if you want to, for example, that all your value between here to here become another value, so you can use the histogram, you check the histogram, and then you can bring in the function, manipulate this histogram with the AWK, and having a new column table with inserting in the PK class. Okay, let's see what happens. So if I run this line, I have this input. So I can see my temperature of the class. Okay, temperature of the class. So I have, before there was my histogram, now I have this one that I have been implemented. So I can see from 61, you remember, no? You remember it was going from 61 to 93. So now I get it. Print $1. So if it's bigger than 75, print $1. So the same value. Else print $1, 1. So let's see what is happening. So over here, print 0. So less than 75, print 0. So I have less than 75, print 0. Oops. Less than 75, print 0. And bigger than 75, put 1. So now this file become the lookup table for my new file. So now with the PK reclass, I can, with the PK reclass, I can use this script, this text file that I just create with the input, and going to apply my my file, and is going to become the reclass. And now my reclass file is going to be my teeth that I can open with the open AV is going to be 0, 1 in according to the classification. Okay, so this one is very similar what we did with PK set mask. Perfect the same. You can do it the same way. So the advantage is with this one, actually, usually you don't do it for, you know, let's do something cool. So let's do this one. I have this one. I have my histogram that we just created. Can I, if I want to, you know, yeah. So this one is my, you know, my histogram. So my histogram was this one. Can I do it rather than having the file, for example? Rather than having my value starting from 61, you know, can I start it from 1 and having 1, 2, 3, 4, and so on? Okay, there is a easy way. You could just subtract 60. But let's suppose, and here you don't have it, that one of these is missing. Okay, you will not a continuous value. You will not have a continuous value. Okay, so you will have 71, and then this one will be 73. Okay, so rather you can use this one. How you do it? Okay, let me do it. AWK, let me copy it here. Okay, grep -v, -v, and I do it perfect like this. Okay. Now what I do? I print the column number 1. Okay. Column number 1. Print, and I'm not interested in how many pixels, so I'm printing only the number 1, and here I print what? Number of rows. Okay, so now I can use this one to reclassify my image, and I will have a file that is much smaller in terms of pixel value, and if there is a jumping, you know, I will be reclassifying according to my number of row ID. So there can be some cases like this one. I use it quite a lot. Okay, so now I can create my new file. Okay, that is going to be reclass dot underscore number of row. I put it, for example, 60. So now I can use PK reclass with -c. I think with -c. Yeah, that's code. Is going to be my reclass NF, and then input my file, that is this one. Yes. Okay, so now I can do that one, and now my new file is going to have a continuous value from 1 to 0 to 1. Okay, now I can't see because they have the typical 99 over here, so I need to use it GDAL edit to GDAL edit --99. Now, if I open, my node data is going to be labeled 999, and here is going to be from 1 to 33. Okay, so I'm sure that it's starting from 1. So this is how you use the reclassify option, and I use it quite a lot, especially when working with polygon ID and so on. but you can. It's not a reclassification like in thinking like maximum likelihood classification. No, it's not statistical. It's just a recoding of the image. Okay, so and this one is very. Of course, you can. I don't know if you can implementing any masking in this one. Probably not. But again, you can apply the masking later on. You can reclassify also the pixel that you don't want it. You apply the masking later on. Yeah, this one you don't have any. Look, this one, for example, I never use it to develop. Probably you can reclassify based on a shape file. This one I never use it. And then of course you can change the output type. For example, now you know that it's going to be a byte because everything is going to be short, smaller, you know, so you can do, okay, now I'm pretty sure that this one can be output type byte, okay? You still have the -99, so this one will be converted to 0, but doesn't matter because yes, you will have the file. The 0, you start from 1, you don't start from 0, so you can convert it to output type byte. Okay, so now you can open without the GDAL edit because the 0 will be not so far, even if it's not loaded. Okay, so this one you can see now that you have over here is 0, and over here you have all the values. So this is how you play with the PK of the class. So it's just a matter of you know, there are plenty of them, plenty of these tools. It's just a matter of combination, you know, because of course you have to do something and then masking and then to do the PK class, and then it's more or less like any kind of GIS software that you have to do in step in order to arrive to the final solution. But this is how you implement it. Then let's see the last two options, the last two example. You have the typical zonal statistic that was asking me in the previous lecture. So you can have a zonal statistical for polygon extraction, and then you have the zonal statistical for point extraction. So like very similar to what we did with the digital location. So here you can identify, you know, a source file that is going to be your polygon file, vector file, okay? Then you can have your source file as a raster to be calculate your zonal statistic, and then the final one is going to be your vector file where you calculate your zonal statistic, and in terms of what? In terms of mean, standard deviation of the zonal statistic, and over here you can specify whatever you want, okay? As a rules, as an algorithm. It's something also extremely beautiful that you can identify also the source of, you know. So during the zonal statistic, please do not count or do not do the math when encountering this value. And probably you can insert even more than one, probably. If you quite often there is the S between, let's see. One is PK oops. Yeah, PK start OGR. PK start. Yeah. S between brackets means that you can specify more than one. Okay, so you can have source no data, you can have more than one. Okay, so now I'm not sure, but usually when I do it, I repeat perfect the same. I repeat, you know, again the same flag with another value. But could be that you need to do like you can do it like this, but I'm not sure. One will need to check. So could be that you can do like this. Okay, so this is extremely beautiful. And also something very, very nice that you can identify the format. So for example, here I was output a shape file, but here I was output a CSV file. And then having a CSV file, what you can do, you can manipulate with WK. Rather, so if you go here, you go geodata, and then geodata SHP, you can see -P, the last one, you can see that my polygon, my output, okay, underscore stat is a CSV file. Okay, so where I have my value, mean, standard deviation, just calculate right now, and of course is a long file, and I can, okay, now it's just 3 polygon, but it can be longer. I can manipulate with the AWK and do some other kind of analysis. Okay, so the beauty is that with the zonal statistic, you get something that is already available as a vector format, but also as a TXT file that later on you can manipulate, you can import in R, in Python, whatever you want. Okay. Something similar is the zonal statistic, the zonal point extraction. So we were doing the CSV, sorry, we were doing the GDAL location info. This one is doing pretty the same, but with the one advantage that you can, you can identify at point location, one specific point. But okay, this one, I don't think there is any. Rather, you can do it to also identify at point location plus 1 pixel beyond, 1 pixel around it. And around the 1 pixel, you can, you can get the mean and the standard deviation among the related values. So this is also very cool, because, sometimes we get the point location, 1 point, like species distribution, we get to that point. But I mean, if it's a bird that is moving, it can be also, 10 meters far away. So it's better to get also the value in the nearby pixel. So it's quite handy. Also, this one you can create a CSV file, and be careful about this one. Always when you deal it with the vector file as an output, always remove before. Okay, always. Because quite often they are not going to overwriting, and sometimes they even appending inside, like the geo package. So once I was creating a geo package very huge because I didn't know, and he was just appending inside without any kind of warning. Okay. So these are the application. Yes,
I have
Anna.
a short question on this command, because you said, or it's written there, that it's like at point location plus 1 pixel buffer, but with this -BUF argument, we are passing 2. So does this mean one would mean only the location, or is this an error there, or what's the...
Yeah, good point. This one should be, and this is something that I was going to test and check. This one, because you put, the pixel himself plus 1 around it. That's why you put 2. Okay. Okay, but it's something that needs to be tested. And also, when you're dealing with the PKTOOLS, any kind of counting starts from 0 because it's a C+ base. Okay. So when you identify the band, for example, band 1 is not band 1, it's band 0. Okay.
Yeah, that's why I was wondering, because in the help it also says the default for this buffer argument is 0. So yeah, that's why I was wondering.
Yeah, it could be that over here
yeah.
should put 1 because the 0 is the point himself. Yes, for the pixel around it, but need to be double check to be sure. I didn't use so much this function, so, and especially when I'm not sure, I have my little thief, like I mentioned, I put 1 pixel in the 1 point in this little thief, and I see the math around it, and I identify sometimes what you use over there. But actually, also this one doesn't make sense to calculate in the standard deviation if you have a point. So I don't remember why. Anyway, so this is the way how to all the combination. Of course, we didn't check all the PK tools, you know, PK. There are plenty of them. Okay, so once again, any kind of a raster manipulation and also vector, you can do it with GDAL and PK tools. It's just a matter of combination. Okay, combination. Sometimes there is not, you cannot do it with only one command, but you need 3 or 4 commands to arrive to your final task. Okay, but all of them can be done. So just try to play, get some simple tasks that you want to do it. You know, that can be merging of image, that can be resampling, reaggregation, reclassification. You know, this one, for example, this one can use it for statistical insight. I didn't use so much statistical insight OGR. OGR means vector file, you know, inside vector file. This one for the Kalman filter, okay, and so on. There are plenty of them that I did. This one for color raster color table. Raster color, the color, making raster a color table. Okay, so this one I used quite a lot, especially for global view of identify some pattern and so on. Okay. Any question in these regards?
Yes,
Yeah.
I had. Sorry, someone else. I have
Yes.
one confirmation. So you said PKTOOLS is 0 indexed, but I think if I remember this correctly, GDAL is not, right?
No,
It's 1
GDAL
indexed.
is
Okay.
1. Bravo. Yeah, GDAL is 1. Be careful. But yeah.
Yeah, that can mess you up. And then my other question was for PK extract. What is the default? So let's say I have like the corner of my polygon goes through a pixel. So how much of the pixel has to be inside for it to classify as inside?
I think, good question. This one, I think there is something in there, but I'm not sure.
And can I specify like a buffer? I mean, I can make my polygon smaller, right? That's of course a way to do it.
Yeah, so you can even, you know, reduce the pixel resolution and having all the pixel inside to them. So this one, maybe this not show the. I'm not sure that you can identify these. Usually, I always play with it, reducing or increasing the pixel resolution. In this way, you know, if you increase the pixel resolution, all your buffer will be included inside the polygon or all the way around. So I do it this kind of operation. But it's something that you can test and investigate, but I'm not sure that you have this kind of flexibility.
Because there's actually, so in a past project, I had a bunch of polygons of farms in Austria, and they can be very small and narrow. And I needed to find out whether for each field, is it big enough to contain at least one full Sentinel pixel? I did it with in PostGIS, I think. But yeah, I was wondering if it was able to do it with PKTOOLS.
I mean, you can play, you know, in that case, you would do it a kind of weighted statistic as a function of the area that is in overlapping, okay? In that case, for example, I would create a raster with a pixel area value, very small raster, pixel area value. I would calculate the sum of the area of the pixel area raster. And then I would do the same, making the sum of your NDVI, and then doing a weighted function between the two raster that you obtain. So you need to, you know, you need to work around to have, you don't have a tools, but a combination of 2 or 3 you can calculate.
Yeah, makes sense. Yeah.
Okay.
And maybe one related question: if we want to, for example, to not to calculate statistics, but like but just to take a point sample of some raster values. For example, we have some point like weather stations or like some other observations which are located on points, and we want to take sample of raster. Can we do this by these tools, or it is something?
So okay, so if you have, if you have station, you have the lat long of that station, so you can use it GDAL location info, or you can use it just the last one that we just see. Okay, so over here in the zona statistic point extraction is, this one is going to be your station with lat long information of the station. Okay, so rather if you want to create a random point inside of the image and sampling there, actually this one is something that I used the other day. One of these two, they have the function random that you can say, okay, I want 10 random points inside to the image, and he can create a random point inside to the image. So I use it the other one. I think is PK extract or GR, one of the two. Yeah, this one. Create a sample random points to generate. This one you can use it to generate random points until the image. Okay. Many of these implementation of tools in a real, very well procedure is inside to these. So if you go to the today lecture, you have two assignments. The suggested one is just get familiar with the tools, apply to all GDAL and PKTOOLS, because now you have everything in your head and your finger. And for next week, so for Tuesday next week, you have to follow the lecture before the class, the lecture that has been recorded here. Okay, so this one is a real implementation of a real study case of Landsat image with temporal filling, temporal interpolation that we did together with one of my PhD students for using PKTOOLS. Okay, so over here is really that you see the full implementation, this full scripting procedure. You can download the data set. They told you how to download the data set over here, and you can see the full explanation. Once again, there is the video recording over here, so you can follow me talking last year. Okay, so this is something that we'd like that you do it in advance of the class. In this way, Tuesday, we are going to have a Q&A of, all the spatial implementation, because this is done, let's say. So do this one, come with your scripting procedure that you have done for your study analysis. In this way, we can comment it, we can ask him, we can try to do this kind of round table of question, okay? Yeah. Okay, Alex.
Okay, thank you.
Yeah, and any other question in this aspect? All the people that are
may I ask
yeah.
a short question? Is that when do from your experience, Giuseppe, like what type of actions we use PKTOOLS while we use GDAL? So like is there like a SOP? So in some actions we'll just try to memorize the PKTOOLS. Some will just use the GDAL.
I mean, the GDAL, you have to think that is something easier, not easier, but classical, like cropping, reprojection, rather PKTOOLS is a bit more, getting an histogram, thresholding an image. So it's still in the pre-processing, but it's not the real beginning of pre-processing, let's call it in this way, okay?
Like a shortcut, it's kind of like a
there is not a real rules. Most of the tools, I would say half of the tools, they are in overlapping. So you can perform the same operation, but I would say try to simplify your procedure in a step. Check each single step, what you have to do, and searching for the tools. Okay, it's a matter of try and try and try, because there is many. I mean, there are many combinations, you know, that you can have, and think in not in the final. I mean, you have to have in mind your final goal, but then try to simplify your step, and then search the tools that does that step. You know, because you can do everything. You can really do everything. But it's a matter of many hours of trying. So try start as soon you can. You know, yeah.
Okay, thank you.
And try with the real data, you know, download few Landsat image bodies, whatever you want, digital elevation model, whatever you are dealing with. In this way, you can say, okay, let me try to do the maximum value of all the image, because I want to see the highest mountain, or I don't know, you know, this kind of operation that you keep asking for some analysis of your data. Okay.
Yeah, thanks.
Okay. Okay, any other question, people that are silent or lecture want to say now or never?
I had a question. I think there
Yes.
was another, when I was going through the lectures, there was another assignment that seemed to be compulsory about the multi-core operation, but I kind of missed that. Is that, are we
Okay,
doing that,
right,
or?
good point. Yeah, good point. Please also follow up the lecture of, I mean, in the day of yesterday.
It's the 11th of
18,
April.
18, 13, yes. Yeah, this one. This one also follow these. So for the lecture of last lecture, there is this compulsory assignment that, okay, it's a compulsory in the sense you have to watch the video recording. And if you click over here, there is an explanation with a video recording of the multi-core operation in Bash, okay? And this is also very cool. And now that you have the GDAL implementation, there is an example with the use of GDAL for multi-core implementation. Please also check the video that is going to tell how to increase the CPU in your machine by the setting of the virtual machine, because the virtual machine as a default, you are implementing only one CPU, but you have two, is going to be used in multi-core. And as I mentioned, these GDAL and PKTOOLS, GDAL even more, is using very low RAM. Okay, so it's very easily that even in your laptop, you have 8 core, you can put 5 of them to work with your analysis without filling up the RAM. Okay, PKTOOLS is using a bit more, but it's still doable to use it multi-core in a laptop. Of course, don't go crazy, because if not, you froze everything, and don't go crazy in the virtual machine. Okay. And this is very cool because it is explained very well with a real simple case that you can see the CPU going 1, and then when implementing the GDAL, sorry, the multi-core, you have the 2 CPU running. Okay. And you will see is a for loop that become a multi-core loop. Okay, so it's very, I go simple and then I change it to the multi-core for loop. And this is a good starting, because then, you know, you can have in the same thinking, you have the so-called multi-language integration. When you start to combine Bash, Python, and R even all together, and having, you know, Bash that is running 3 times Python computation, for example, because each single Python does something in the TIFF. Okay, so this is where you really become efficient in the multi-core operation. So I really suggest to do it. Okay. Okay, good point. Any other question? So remember to come with example and explanation, lecture, recorded lecture, watch it. So you will have a busy weekend. Unless you start today. You start today and tomorrow, and then Monday you can manage. Okay. Samuel, you can start to downloading the hydrography 90 meter, start to play with them, merging, operate, you know, point extraction, all this kind of operation.
Okay. Thank you very
Yeah.
much. Yeah.
Yeah.
It's all on the 90-meter scale, right? The 90 meters.
90 meter scale, yeah.
Yeah, okay.
Of course, don't download the full globe, just a few tiles.
Yeah.
Okay. Okay.
Okay, thank you.
See you next Tuesday. Bye-bye.
Okay, bye-bye.
Bye.
Have a great
Thank
weekend.
you.
Bye,
Bye.
bye, bye.
Thank you. Bye.
You